In the previous video, we have created our AI script called AI agent. Now what we will need to do is to create some controller, so AI director for example, and this script will drive our AI agents. So we are going to test in this video how our AI agent can act when we create a simple city and we will spawn our AI agent to move along the road or the street from one structure to another. So let's go to our scripts folder, AI, and let's right click, create a C# script. Let's call it AI director. Okay, let's open it up in the Visual Studio. Great. Again, let's delete everything from start and update, so everything that Unity has pre-created for us. Let's put our AI director in our namespace, our simple city.ai. Okay, so now we will be consistent with our system for the AI. Let's save it. What we are going to do here is we are going to use our placement manager script that contains a grid, which is a graph that stores all the different data about our map. So where is the road, where is the where are the structures, and overall it is used to get access to our map and to get the access to our data on our map. So let's create public placement manager, and let's call it placement manager. Next, we will need to have an array of game objects. So public game object array, and this will be the array of our pedestrian prefabs. So this will be the AI agents basically. So pedestrian prefabs. We are going to spawn those and give them path to follow. Okay, great. And for now, I think that's it. Now let's create a method, public void spawn all agents. And we are going to call this method from our UI, and we are going to try spawning all the agents, or rather we are going to spawn the agents in front of every house and every special structure, and we are going to give them a random structure from another group. So for the structure house, we will give it a destination a special structure, and for the special structure we will give the agent a destination as a house. So for each tab to create this from the snippet, for each var house in our placement manager, and we have a method called get all houses, which will get us all houses from our graph structure. Now we are going to call try spawning an agent, and we are going to pass it a house. So I have misspelled it, house, and our placement manager get a random special structure. And that's it. This is how we are going to put our give our agents a start point and a destination. Alt enter on this method since we do not have it generated, and we are going to do the same. So copy this for each loop, and for our special or our special structure in our placement manager get all special structures, and we are going to pass the special structure instead of the house here, and we are going to get a random house. Okay, great. So now let's implement the try spawning an agent. Here we will want to check if our start, or we should rename the parameters as start structure and our end structure. And the structure model is a helper class that will be placed on a game object that will be a parent to our game object representing a house or the shop. So we have this reference, and its position is the same as the position on our grid of this certain this concrete structure. So we are going to first start by checking if start structure is not null, and we are going to check if our end structure is not null as well, and our end structure is not null, only then we are going to call to find our start and end positions. So now you can see that our structures are of type structure model. So let's right click on it, go to definition, and this is just the script that helps us to correctly place our structure, and it helps to swap models when we are placing the road. Again, I send you to the previous tutorial if you want to know more about the setup, but a new thing that I didn't mention before is that it has an interface iNeedingRoad, which contains a property of type vector3int road position. And now if we right click on it, go to the definition, find all references, and we can find all references in our scripts. And what we will need to do is find this var structure model equals structure model add component, and this method resides in our placement manager. So another thing that I have forgotten to mention beforehand in the second video of the series is that we have our method called place objects on the map, and I have added a couple of lines of code here that sets a nearest road position for each structure so that we can access it when we want to find a path between each structure. So each structure now knows where it is positioned, so which road cell is closest to the structure, and then we can use it. We are finding it using this get nearest road method, and then we can use it when we want to create a path between two structures. So I'm going to use Ctrl- to go back to our AI director. Great. So now we know that our structure model is implementing the iNeedingRoad interface, which contains a road position property. So we can retrieve this by getting simply the start structure and end structure and casting it to our iNeedingRoad interface. So we are going to do exactly that. Var start position equals our open brackets, another brackets, iNeedingRoad, and we are going to call start structure, and we are going to get the road position. And let's copy this line because we are going to get in the same way the end position. End position equals iNeedingRoad end structure, and we are going to get the road position as well. And since those return a vector3int, they are not null, so we do not have to worry about it. So what we can do is instantiate a var agent equals instantiate, and we are going to get random pedestrian, so call get random pedestrian. Okay, we do not have this method, so alt enter and generate it. And what we are going to pass here is the start position and quaternion dot identity. Okay, let's quickly implement this get random pedestrian. We want to modify the return value to be game object, and we are going to simply return a pedestrian prefabs, and let's type unity square brackets unity engine dot random, since we want to use this random range from 0, so open brackets from 0 to our pedestrian prefabs dot count. This is length because this is an array, and we are going to get a random pedestrian from our array. Let's slide down back to our try spawning an agent, and now what we can do is call var path equals our placement manager, and it has a method called get path between, and we are going to pass here our start position, our end position, and we will want to pass here a argument true. Okay, and we have an error here. Let's go to right click, go to the definition, since we will need to pass here to our a star search a parameter at the end. So let's type bool is agent, and let's pass this is agent bool value to our grid search a star, since it takes a bool value and is agent is by default false, so we are going to pass it a value true. Let's set it to be false as default, because other methods rely on this get path between. Okay, Control minus to go back to our AI director. So we have our path calculated on our current grid using the A-star algorithm. So now, by default, we should be able to calculate a path and then give it to our agent. So let's just check if our path is the count is greater than 0, since sometimes there might be no path between those two positions, and we will get a path of equals 0. So no path was generated. So if our path is greater than 0, we are going to call path.reverse, since our A-star returns the path from the end position to the start position, and we are going to call our var AI agent equals our agent dot get component AI agent, so the script that we have created, and we are going to call AI agent, so our script reference, and we are going to call initialize, and we are going to pass here a list of vector3. Now do mind that our A-star has returned a list of vector3 ints, so we cannot really pass here a path between. This will yield an error. So instead, we are going to create here a new list vector3, and in the brackets of it, we are going to call path.select, Alt Enter to import using system.link, so the query library. We are going to select, open brackets, x, so this is a position of vector3 int, such as, so lambda expression, our x, we are going to cast it to vector3. So vector3 in the brackets and pass x, and this select statement now casts our x to be vector3x. So all we have to do is pass to list, and we are going to get a list of vector3s instead of vector3 ints. So our initialization method will work. Now we have this link library usage here because later on we are going to implement a method to calculate another path, and this will return us a path in vector3 values. But for now, let's use it just to represent what is going on in our game. So let's save it. Let's go back to Unity. Okay, great. So now let's go to our scene. Let's right-click in the hierarchy, create an empty object. Let's call it AI Director. Okay. Reset its transform. Add to it component AI Director. Here we will need to pass a placement manager. So let's drag our placement manager from the hierarchy here. And we have our pedestrian prefabs. So let's go to our prefabs, people. Let's drag our pedestrians here to our array, and we should be good to go. Last thing that we will need to do is actually spawn our pedestrians. So let's right click in the hierarchy UI, create a button. Actually, we have our canvas. So let's choose the canvas, right click, UI, button. Let's go to our scene, choose the 2D view, and choose the button and F to focus on it. And we are going to use the move tool to move it somewhere to the corner. Let's open up this button, change the text to spawn pedestrian or spawn agent. Agents. Great. Choose the button. Let's slide down in the inspector. Let's choose the on-click event, add an event, drag our AI director from the hierarchy to the space where there is object, non-object, and let's choose the function AI director, and let's choose to spawn all agents. Okay. Now do mind that in the main camera we have the functionality to move the camera as well as to scroll to zoom in and out using those max and min orthographic size and sensitivity. So now we should be good to go to press play, and we should be able to slide to zoom into the map, so using scroll wheel. So let's create a road, let's place a house, let's place a special structure, let's zoom in, use the WSAD or arrows to move to the nearest house, and choose the spawn. And you can see that our agent was spawned on the road nearest the house, and it is traveling through the road. Now, as you can see, this isn't the perfect setup. Another agent has started from the opposite side of our road, And you can see that our agent is traveling to the road, through the road to the selected destination, and when it reaches it, it disappears. But the issue, as you can see, is that it travels through the middle of the road. When we walk the streets, we usually use the sidewalk. So the issue is that we do not have a functionality to use the sidewalk using this basic A-star search and the grid structure that stores only the informations about our structures and our roads. We need something more granular. So in the next video, we will implement markers on our pavement, so our agent will traverse using those markers, so the positions when our agent can move rather than moving through the center of the road. So I'm going to explain how we are going to do that in the next video.